Good afternoon, everybody. Welcome to our grade 4 coding class for today, 22nd of July, 2020. Today, we are going to go back to our functions, functions with artist. And yesterday, we took a little break from functions. We moved it just to have a look at something a little bit differently, because we did do functions for I think 2 or 3 lessons before that, but then we still have a lesson on functions with our artist, and we're going to go back to that today. For those of you that don't know me or might have joined me for the first time here or on YouTube, my name is Mike Geldenes, and let us quickly look at our objectives today. We always have a lot of fun and we interact. So I want you guys to also be patient while I explain some concepts before we go to code.org. And then once we are at code.org, then I will share a link with everybody, and then we can get to our puzzles and try and solve the puzzles they give us. So I want to just quickly say that there are going to be a few things that we're going to go through before we actually move to code.org. And I really want you guys to pay attention, because I think it will help you a lot. We're going to look at some angles, and we will be just looking at some of the functions itself as well. So be patient if you understand it, because I have been asked to go through it a bit slower, and also just to explain the angles, those kind of things a little bit more. So if you do understand it, I'm so glad. But if you don't, please be patient. Let's go through it together, and then see if we can learn something new today. Okay, guys, so what are our objectives for today? And yes, that is a zombie. And I said this is going to be functions with artist. It seems like today our zombie will be the artist. So that's a little funny, but I'm sure that he can draw pictures. He wants to draw pictures as well. Okay, so guys, what are our objectives? To recognize when a function could help to simplify a program. Now, I know some of you might not know what a function is yet, but I'm going to review that with you guys as well, so don't worry. Then our second objective is to use predetermined functions to complete commonly repeated tasks. Now remember that sometimes they give us functions that are already coded, and sometimes we have to make our own functions. So I will show you again how we will make our own. But other times when they just ask us to complete an action, we just go and recall the function that they have already written. And we can also look at the code at any time to see what is in that function. So you don't have to worry about that. So you can always check what a function is going to do. Okay, guys, so let's quickly go through our slides, because I do want us to get to the puzzles as well. What is the purpose of functions? This lesson is meant to further push us to use functions in more creative ways, okay, by also using conditionals and loops. So the first couple of functions we did, we only wrote a new function, or we used a function as the entire code. Now within our functions, we are also going to put conditionals and loops, and we will learn there are many ways to approach a problem. And we've seen that every time we ask somebody to help me out to solve a puzzle, we see that everybody approaches this slightly different, so we all think a little bit differently. And then also to improve our problem solving and critical thinking skills. By doing these things every day, then you know what, we are going to be more capable of solving problems and thinking of how are we going to solve things. So guys, let's quickly look at some of our vocabulary words that we're going to be focusing on. So what is a condition? Because we said we are going to use conditionals and loops. So a condition is a statement that a program checks to see if it is true or false. If true, an action is taken. Otherwise, the action is ignored. And for those of you that are new, my students already know I like to use the example of a tree, so of an apple tree. So as long as there are apples in the tree, you will pick them, okay? But once all the apples are gone, then you're not going to try and pick an apple because the apples are gone. You're going to move on to a different tree and then try and pick an apple in the new tree. Okay, so as long as there's a statement is true, there are apples in this one tree, you will go and pick them. As soon as there are no more apples, then you will move on and then perform a different action or go to the next tree to find an apple. Okay, so that is a condition. Then a loop. A loop we will put if we want to do an action over and over again. Now I'm going to use the same thing about the apple tree. So now we have 5 apple trees in a row. So the first apple tree, you will pick apples until there are no more. Then the second apple tree, then the third. So then that is a loop. You will perform the same action in more than one place. So we're going to go from tree to the next tree to the next tree. Okay. And yes, guys, I will share the link for you guys as soon as we go to code.org. But there are a couple of things, like I mentioned, that I just quickly want to explain to everybody. So let's quickly go through that. So the faster I can get through these slides, the faster we can all go to code.org and play around with the puzzles. So a function, that is our focus today, is a piece of code that you can easily recall over and over again. So if we look at our new toolbox, because we have so many commands and loops and conditions, our toolbox looks a little bit differently than usual, and we actually have to go and find what we are looking for. So for example, now they will only give us a category. So here we have actions, loops, conditionals, functions, and comments. So for example, if we are looking for a function or an action, you have to go click on the option you want. So select the action you'd like to perform to see the available options. So I've got actions, and now inside actions, I will have move forward and right, pick corn, pick pumpkins, pick lettuce. And in this case, it will be a little bit differently because we are going to draw. So maybe there will be jump or draw or move. So it depends on what actions are available. It would depend on what we want to do, of course. And then we can also, if we look at this, there is the function in the code. So when run, repeat until there are pumpkins. Do, and what are we going to do? Move forward and check square for corn. So there is a function already, and then those are the green blocks. But like I mentioned, at any time, we can go and look to see what code is written into this function block. And remember the functions, if we write our own function, we can give it any name we want. And I can think of, we did a garden in a square, and I think Zivan still named it for us. He said, I think the name was garden in a square or square garden, something like that. So we made our own function that we used over and over and over again. So for example, this one here, you can see it's check square for corn. And what is that function? What is inside that function? Inside that function we have, if there is corn, do pick. Then we can write anything depending on whether, today we're going to draw pictures. So we are going to, for example, if we want to keep drawing a square, then we can make a function that we can just change the name to square, and then we can write the code inside square. How are we going to draw a square? And then every time we want to draw a square, we can just click the function block, just the one block, and we don't have to write the code over and over again. We can just recall it anytime we want. So let's quickly see what I wrote on the screen there. Function, a piece of code that you can easily recall over and over again. And then here we can see the function. Okay, great stuff. Here I have an example of, I think this was still a homework puzzle I gave everybody, but this is just an example of how we solved it. Okay, so if we look here, we've got 3 functions. The first function we wrote was pick a long path. Okay, and we might ask, what is pick a long? Let's start at the bottom, because look, in pick a long path, you can use a function within a function. So in this pick a long path, we've got 2 other functions. We've got check square for corn and get all pumpkins. So now we want to see, what is check square for corn? The code for check square for corn is, if there is corn, to pick corn. And then we also have get all pumpkins. What is get pumpkins? While there are pumpkins, pick pumpkins. And then we can see this is the code we wrote. This is the only part that we wrote, because these functions we did before we actually started coding, okay? Because we knew that along our path, we will come across corn and we will come across pumpkins. And to pick those, we needed to write a function for each of them. So now we only had to put in pick a long path, and no matter whether we got corn or we got pumpkins, because the code is written into, let me just change to my pen here quickly. There we go. There's my pen. So because this code, this function was put into that function every time, and this one was put into the function. So every time we use pick a long path, all of this will be performed just by using that one block. So it does show you, once we start getting to a place where we use the same actions over and over again, writing a function will use so much space. Because now think of how long this code would have been if we had to write all of this. Forget about the green parts. Now every green part you will have to put this in. So if we had to put all this code right here every time, so it would be quite long. And so you can see that functions really save a lot of time. Then I quickly want to show you guys, this is how we create our own function. So we've got that. We will just type it in. For example, here we typed in make a square. And then every time you've created a function and we've wrote the code, then if you go to functions, you will find that function as a new block. available to use. So you can write a whole bunch of functions and save them inside your function option. And then you can just go back and recall them as many times as you want, and you can just drag them in. Okay, guys, enough here. Before we actually go to code.org, this is a very important part. I want everybody to listen very carefully and pay attention, because I'm quickly going to go through this. And then once we've done this, then we will go to code.org and I'll share the link with everybody, and we will get busy with the puzzles. Okay, but I have noticed that this is a part where we do struggle a little bit, and I've had students ask me, can I please just explain this a little bit in more detail? So I want you guys to please, I do understand some of you already know this, but please be patient. And then while I'm busy here, I can't jump around and from code.org to this. So I hope you guys be patient with me and listen carefully. Okay, so here we have our artist, and our artist wants to move in a certain direction. No, that's easy. Everybody understands that. There we go. We are just going to, let me just take away. There we go. And he is going to move forward. That's very easy. We just use our command move forward, and then we have to turn. Now, normally we turned left or right. Okay. So, but in artist and some of our other puzzles, we have to use degrees to turn. Okay. So for example, he is going to turn now. And there, if you think about your little compass that you use in math, okay, that will help you visualize how big your turn is going to be. Okay, so if we look down here, we see we start at 0. And then going all the way around this way, we go to 180. And if you turn 180 degrees, you will turn around and go in the opposite direction. Okay? And remember, if you turn 360, you'll be looking in the same direction. Okay, so let's say our zombie artist wants to turn 30 degrees. That is going to be the angle that he is going to turn. Now you can turn, if the option is available in code.org, you can turn anything from 5, 1, 140 degrees. So this is just a visual representation of what actually happens when we turn. 60 degrees, that would be the angle. And this is what we spoke about, I think it was on Monday. A 90-degree turn would be either left or right. And we use 90 degrees. If you know math, you'll know that a square has got 90-degree corners. Okay, so here we have a 90-degree corner. So if you just want to turn left or right, we turn by, or up or down, we turn by 90 degrees. Okay. There's a bigger turn, we will turn 120. Now I want you guys to remember, you can see that there are numbers on the inside and on the outside. But remember, we are facing this way, and we're going to turn from here this way. So we go to the outside. If he was facing the other direction, if he was facing this way, then his turn would have only been this way, and then that would be 60 degrees. But then that would be a different direction. We will still talk about the directions. This is a little complicating, so I really want you guys to pay attention to this. So I want to give you guys an example quickly. So here we have our line, and our zombie turned 30 degrees. Now he wants to turn again. Now this new line that we drew, this is going to be our new baseline. This is going to be our new baseline. So then you have to imagine your compass being on that line. Okay? So now if we turn, here's going to be the direction we're going to turn into. And let's say, for example, I want to turn 120. I go from here, here's 0. I go all the way around, there's 120, then I'll be moving in that direction. Okay, 120 degrees. Now here is where I'm talking about which side we are going to talk to. Because that is a 120-degree turn left. We can also have a 120-degree turn to the right. And that is where it is very important to focus on our character. Which way is our character facing? Which way is he moving? So in this case, if we look at this line over here, we turned 30 degrees and he drew this line over here. So this line here is this line over here. Okay? And our artist is facing that direction. Now think about yourself. If you are standing there, you have a left hand and a right hand. Okay? So if I say there's our left and our right. If you lift up your hands, put them out to your sides, even if you face in any direction, you will have a left side and you will have a right side. Now you have to imagine, if you want to turn left, that is our line. We are going to turn left and we're going to turn this way by a certain number of degrees. Okay? But we can also turn right. And now you have to imagine putting another compass on the other side. And then don't look on the outside now, because now that we always start at 0. So this will be then on the inside. And then you can turn this way. Okay. So there will be a left 90 degrees will be over here. Right 90 degrees will be over here. Okay, so I hope you guys understand that. You will have a left and a right. Okay. Now, the last thing I quickly want to show you before we go to code.org is if we draw, that is the same, so we can turn in any direction we want. But what if we get to a shape like that? Okay. What do we do if we get to a shape like this? Now, our zombie will still draw the first line. So let's say he started right here in the middle. Right here in the middle, and he drew this line. Okay. Now, which way is he facing? He is facing in that direction. Okay, he's facing that direction. Now, if I tell you guys, I want to turn 60 degrees. Now look where 60 degrees is, right here. Okay. So the first thing that we will do is, our zombie is facing that direction. We are going to turn 60 degrees. So which way is our zombie facing now? Now our zombie is facing this way. So he is looking in that direction. But he is standing right here. He's standing right here. We are just turning him to face in this direction. I just want you guys to show you. So those two arrows are the same. Okay. Those two arrows are the same. He is facing now in that direction. He will jump back. Remember our jump action where we move without drawing a line. So we can move without drawing a line by jumping. So our artist will jump back to the middle, and then because he is facing in this 60-degree angle, he is going to walk forward in that direction. Okay, so I hope that helps you guys understand it a little bit better. Okay, now we have to remember that after we've moved, and this is our point where we are standing right now, that becomes our new base. Can you guys see? That becomes our new base. So now he is here. What are we going to do? We are going to turn 60 degrees first. Turn 60 degrees, that's over there. Then we're going to hop back to the middle. and we're going to draw a new line. And then this new line we draw, that has become our new base. And then again, you can see every time we just turn 60 degrees, hop back to the middle, move forward. So that is the way we can make patterns like that by turning in a certain direction, jumping, and then just moving forward again. So I hope this explains degrees a little bit better to you guys, so that once we really get stuck into moving our characters around, that we don't struggle to figure out what is happening now, what is going on. Okay, so I hope that helps, guys. So thank you for bearing with me. And now we can go to code.org and we can get down into our puzzles and see what we... So if you guys give me a few seconds, let me just quickly go over to code.org on my side. And then I'll share that link with you. There we go. There's my code.org, and I'm going to copy the link, and you guys can find it in the chat box right now. Click on that. And yes, I know that mine, I've got a question here. I don't know what happened. I might have clicked on something by mistake, but I can't change it now. So let's quickly look at the question. Even if mine is wrong, I don't know yet, because I haven't looked at it yet, so we will see. Dante is in already. So here we go, guys. What will happen when you press run? Okay, before we know the answers, we need to go and check what our artist is doing. We've got to draw a square, jump backwards by 175, and then draw a square. Now, what is inside our draw a square function? It is repeat 4 times, because we know a square has 4 sides. We've got move forward by 100, turn right by 90 degrees. So now you understand the degrees. A 90-degree turn is left or right or up and down. So that is how we are going to draw a square. Move forward by 100, turn right 4 times. Okay, that's our square. So what is going to happen if we draw a square, jump backwards by 175, and draw another square? Are we going to A, nothing's going to happen? The function is not called in the program. B, the artist will draw a single square. C, the artist will draw 2 squares that overlap. Or D, the artist will draw 2 squares with a small gap in between. So what's going to happen, guys? Type quickly in the chat box A, B, or C. I've got a couple of answers. I've got a couple of C's. I've got a D. Let's see, what else? I've got some more D's coming in. What is going to happen? I've got a couple of more C's. Don't look at my answer, because my answer is wrong. C, 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 and another D, another D. Okay, yes, guys. The answer will be D. The artist will draw 2 squares with a small gap in between. How do we know that? If we stand here, let's see what is going to happen. We're going to move forward by 100. And we're going to draw our square, and we're going to stand on this position. If we jump backwards by 175 and we move forward again 100, there will still be a space. Okay? So the correct answer is D. The artist will draw 2 squares with a small gap in between. Look at that. Let's just quickly review. So we were here, we drew our first square, we jumped all the way over here, 175, and then we drew our second square. So who can tell me how big is this gap in between? Let's see, who can tell me how big is the gap in between the two squares? How big is the gap in between the two squares? If you use some math, you'll be able to figure out how big that gap is. Remember, our square, our starting point, is the same place because we go around and we stop here. And we know that the side of our square is how big? If we look inside our code, it is 100. It is 100. Now, if I jump back, how far am I going to jump back? 175. So I'm jumping from here all the way to this spot over here. That is 175. And then I move forward 100. So what is the difference between this gap that I jumped and moved forward? And I see only Taryn. There we go. Thank you, Taryn. Yes, guys, the gap in between the two squares are 75 pixels. Remember, we jumped 175, that we see over here. And then we moved forward by 100. So the gap in between is 75 pixels. Well done, Taryn. That's the only answer I got. So good job. Let's move on to puzzle number 2. Okay, puzzle number 2. Now look at what our zombie is drawing. He is drawing a pair of glasses. Okay, so let's quickly read our instructions. Here's a function called draw a square. Use it to complete this drawing. Okay, so luckily they've already given us the draw a square. So how many squares do we have? We have 2 squares. We've got one over here and one over here. So let's quickly run our code as it is right now and see what happens. And look at what they told us here. The squares are 75 pixels apart, but Taryn already told us that. So good job, Taryn. Let's run our code. That is what we've got right now. We've got 1 square in our code. So who can tell me what am I going to do to finish this picture? Who thinks that they can tell me what are we going to do? And I see Zoe's got her hand up first. So hi Zoe, how are you?
Fine, thanks, and you?
I'm great, thank you. So Zoe, help us quickly. How are we going to finish this picture?
I think you have to repeat it again.
Okay, so what, do you just want me to put it in a repeat?
No, you have to also do the line that's on top.
The line, there we go, beautiful. So how are we going to do the line?
So you need to move forward.
Okay, move forward. And how far am I going to move forward? Do you think I have to move all the way, or do you just think I have to move to the second square?
To the second square.
Okay, so how far is this? How big is the gap? We said the gap is 75 and the first square is 100. So how far are we going to move?
We're going to move 75 pixels.
But remember, look at where we are standing right now. We're standing on this side. I'm going to put in 75 pixels and then you will see what's going to happen. Move 75. Let's reset and run. Look where he is. Can you see where our zombie is?
Yes.
So remember, we have to move this distance and this distance. So how big is our square? Our square is, each line is how big? As 100. And our gap, how big is our gap?
75.
75. So what is the total? We have to move
175.
Beautiful. And I see Dante also told us in the chat box, sir, move 175 pixels. And then we will be right here in the corner. And then what are we going to do next?
Then you have to put in draw square again.
Beautiful. There we go. And then we're just going to draw another square. So we go to our functions, we put in draw another square, and we're going to do that. Okay, thank you very much.
You're welcome.
Thank you. Okay, guys, so Zoe helped us out there. So let's quickly reset. Reset and run it again. There we go. And then we finished our code. I'm just going to replay that, and I'm going to make it nice and slow so that you can see each step. So remember, we've got draw a square, which is our function code over here. We've got move forward, which is this space over here, and then one more draw a square. So let's go slowly, reset, go slowly and see what, there's our square. Nice and slow. Then there's our move forward 175. And then we will draw one more square. Okay, there we go. Great job, guys. And I saw Zivan said he finished it. Taryn did it. I can't remember who else I saw. I think it was just Zivan and Taryn that told me they did it as well. Okay, great. Well done, guys. So let's move on to puzzle number 3. Puzzle number 3, and here's that shape I showed you guys. There's that shape. Now we have to write a code or write a function, draw a star. Now we can change that, but oh no, we can't change. That's the name they gave us, draw a star. So we have to write a code inside draw a star, so that every time we want to draw a star, we can just recall it over and over again. So let's quickly look at our instructions, and then I see, oh, we've got so many people wanting to help. I think the first one got her hand up was, I think it might have been Taryn or Sia. I'm just going to check. I think it might have been Taryn that was first. Okay, so as soon as we get there, I'm going to unmute Taryn and she's going to help us. I just want to read through our instructions quickly. Each arm of the star is 25 pixels long. Now remember, we are going to start in the middle. You need to turn 45 degrees to get 8 arms. Remember, if we go in a circle's got 360 degrees to go all the way around. So that's why we are going to need 8 arms. 8 times 45 will give us the 360 turn. It is okay to go forward and backward over the same arm. Okay, so there they give us some tips. We don't have to jump, but we can move backwards. So let's just quickly go and check our toolbox to see what is available. We've got move, we've got jump. So we can either move on the same line or we can jump. It doesn't matter. Okay, so I'm going to go to, I said Taryn, and then hopefully Taryn can help us out with this puzzle. Hi Taryn, how are you?
Fine, thanks, and you?
I'm good, thank you, Taryn. Can you help us solve this puzzle?
How
are we going to write this function? Okay, so tell us.
First, you put a loop that says repeat 8 times and draw star.
Okay, remember the draw star, we are going to write the code for draw a star. So you said we're going to loop 8 times. So great, let's see, because we've got 8 arms. Let's see, repeat 8 times. Okay.
Then
so what's our first step?
by 25 pixels.
Beautiful. Move forward by 25 pixels.
Turn right by 45 degrees.
Okay, so here it doesn't matter which way we're going to turn. If we turn left, we would have drawn the one on top first. If we turn right, we draw the one at the bottom. So it just depends on which way you want to turn. So that doesn't matter, but yes, we're going to turn right by 45 degrees. And then what are we going to do?
Jump back by 25 degrees.
With 25 pixels.
Pixels.
There we go. Jump backward by 25 pixels. Or move backward. It doesn't matter. It will be on the same line. They told us it doesn't matter, but yes, that's good. So we're going to jump backward 25 degrees. And then what are we going to do? Just repeat. So let's quickly see, because that is draw the line, turn, jump back. So let's just run it and see first. Okay. Let's run. 1. Let's make it a bit faster. Okay. So we've got that. I just might have moved something wrong way. So we moved forward by 25, turned, jumped back by 25, and then we have to, and Zoe said she did it. Okay, so what is wrong with this one? There's one thing that we have to change. Because look, we are doing it the right way. We moved, turned right, jumped back. Let's change the jump back to move back, because I don't think he's picking this one up. Let's just change that one. Action, and we move back, because I think they want us to use this move backwards. So let's change that. Instead of the jump, reset and run. Oops, look at that. So let's do that, draw. Let's move first. Move forward by 25, move backward by 25, turn right. So let's run it now. There we go, look at that. Okay, because the only thing that happened there is that we turned and then we moved backwards. And because we turned first, we moved in the wrong direction. So here, if we move, let's just go back there. So move forward, move back, turn, and then move forward, move back, turn. Okay. Okay, well done, guys. So what I want you guys to do, keep practicing this. Figure out what happens if something like that happens. So what happened is we moved forward, then we turned, and then we moved backwards. So then, because we faced in a different direction, our artist moved in a different direction before we did this. So we stayed, moved forward, moved back, so putting us back into the middle. And because on this one, the mistake we had on this one, now in the example that I showed you, okay, we jumped back to the middle point. And here we don't have a middle point. If we jump back, we just jump back by a certain number of pixels. Where the one I used in my example, we jumped back to middle position. So we would start on the same spot every time. So we have to really focus to see what actually happens in this. But there we go. So we move forward, then we move back or jump back, and then we turn right. So guys, that is unfortunately all we have time for today. We're going to carry on with this tomorrow. I know I did spend a lot of time in explaining degrees, but sometimes even if we want to learn a new game, we have to spend some time learning the rules. So sometimes we have to take the time to learn how to do things before we can actually do them. So I hope you guys had fun and that you learned something, and then we will meet again tomorrow, same time, same place. And then if you guys want to ask me any questions, let me just go back to my slideshow. you are more than welcome to. I really want to hear from you guys. There we go. There's our school's email address and also mine, mgeldenace81@gmail.com. And then I'll see you guys again tomorrow. So have a wonderful afternoon. Bye-bye.